This is Codex at rest. One maximized desktop window, a real local project, and a blank task. Everything in this course grows from one loop. Give context, define a boundary, watch the work, and verify the evidence. The environment menu answers where the task should run. Local uses this machine. A Worktree isolates Git state. Cloud uses a managed environment. The choice changes both isolation and what the agent can reach. Git context sits beside the environment. You can stay on the current branch, create a dedicated branch, or use a worktree. Named branches make changes easier to review, commit, or discard without disturbing unrelated work. Permissions control how much autonomy Codex gets. Start with the smallest mode that can finish the job. Read-only investigation shouldn't receive write authority. Full access belongs only when the prompt names the boundaries, forbidden actions, and required evidence. The model picker changes the reasoning engine, while effort changes how much work it spends before answering. Use faster settings for routine edits and deeper settings for architecture or debugging. Match effort to risk and complexity. Pull request is a repository review workspace, not an approval button. Codex can inspect diffs, explain failures, and address feedback. But the human owns merge and release authority. If nothing is connected, the workspace should say so plainly. Scheduled tasks turn a prompt into recurring work. Good automations are narrow, repeatable, and safe to run unattended. They specify the project, cadence, allowed tools, output location, and side effect limits. Later, we'll create one for this local project, confirm its settings, and pause it before leaving the machine. Plugins and skills extend what Codex can do. A skill teaches a repeatable procedure. A plugin can bundle skills, connectors, and tools. The practical rule is the same as with permissions. Install only what the workflow needs, inspect the source or provider, and never treat a capability label as proof that an action succeeded. Our first real prompt is intentionally read-only. It asks Codex to inspect the project, read its instructions, run safe checks, explain the architecture, and identify the known defect without modifying files. Notice how the prompt defines both the job and the stop line. That combination makes the result easier to trust. Once sent, the task becomes a living work log. Codex reads files, follows agents.md, runs commands, and records what happened. You can steer an active task with a follow-up when new information matters, but avoid interrupting just to restate the original request. Let the evidence accumulate. A project can contain one folder or several related local folders. Multi-folder projects are useful when an application, shared package, and documentation live separately. Name every root in the prompt, because the project boundary determines which instructions and files Codex should treat as context. This demo is a small release readiness board. The fixture is the source of truth. The JavaScript modules calculate and render state. Tests cover behavior, and a verifier produces a human-readable readiness artifact. That structure is realistic enough to demonstrate debugging without exposing a production repository or inventing external services. The plus control can attach files and other supported inputs. Attachments are best for evidence that isn't already in the project. When a file is on disk, reference its exact path instead. That keeps the task reproducible and avoids copying stale content into the conversation. The useful part of the answer isn't merely the summary. It's the boundary evidence, which files were read, which checks ran, what remained unchanged, and what the verifier actually proves. A local pass can prove package readiness. It cannot approve launch, deployment, publication, or any other external action. The second prompt narrows the task from orientation to diagnosis. It names the broken behavior, requires a root cause with file and function references, asks for the smallest repair, and again forbids edits. Separating diagnosis from implementation is one of the easiest ways to prevent a confident but poorly understood change. During investigation, Codex traces the value through the UI, storage helper, and tests. This is where a strong agent earns trust. It should connect the symptom to the exact code path, consider malformed or missing data, and explain why the current tests did or didn't catch the problem. Goals are for work that must persist across long runs. A goal tracks a concrete objective and should be marked complete only when nothing required remains. Hard work, slow progress, or an approaching budget is not the same thing as completion. The root cause is small. The stored filter is parsed, but the function throws the parsed value away and always returns all. The proposed fix preserves existing validation and returns the save-supported filter. Small fixes are easier to reason about, easier to review, and less likely to change unrelated behavior. Network access and credentials are separate permissions. A local debugging task rarely needs either. If a workflow needs an API key, use the product's secure setup flow and keep secrets out of prompts, logs, commits, screenshots, and generated artifacts. The diagnosis ends without modifying the repository. That matters. The agent has produced a falsifiable explanation and a repair plan, while the work tree remains clean. We now have a human checkpoint. Accept the reasoning, revise it, or stop. Only after that checkpoint do we authorize implementation. Implementation receives a new contract. Make only the approved filter repair. Preserve the storage key and public API. Run the tests and verifier. Inspect the diff and stop before commit, push, publication, or deployment. The task now has write authority but not unlimited authority. Watch the loop rather than the final prose. Codex reads the target file, applies a focused edit, runs the test suite, and follows any failure back into the code. This edit run inspect cycle is the core of the product. A useful prompt gives it an objective and a verifier, not a screenplay of every keystroke. The side panel can hold files, terminal, review, browser, and side chat beside the task. Files are for navigation, terminal is for concrete command evidence, and artifacts are durable outputs the task produces. Use each surface for its strength instead of treating the conversation as the only record. Tests answer a narrow question. Does the behavior match the coded expectations? The separate verifier answers a broader course question by producing counts, a readiness marker, and the human gate. Keeping those responsibilities separate prevents a green unit test from being mistaken for business approval. Visualizations help when relationships are harder to understand in prose. Repeated mappings, branching state, sequences, or ownership. Sites can turn a local app into a saved version and a production deployment. Preview and deployment are different actions. This core stays local and never crosses the publication gate. If the task drifts, steer it with one concrete correction. Cite the unexpected file, restate the boundary, or ask for a specific check. Don't flood the thread with repeated instructions. Codex retains the conversation, the project context, and the work log, so a precise update is usually enough. Tasks can be renamed, pinned, archived, forked, or handed off where those controls are available. Rename and pin improve organization. Archive removes clutter without deleting evidence. Fork keeps a shared starting context while two approaches diverge. Handoff transfers ownership without pretending unfinished work is complete. The completed result reports 8 passing tests, a passing verifier, a clean diff check, and the exact file changed. It also repeats what did not happen: no commit, push, publication, or deployment. That negative evidence is part of the deliverable because it shows the agent stopped at the agreed boundary. Now, the review panel exposes the actual patch. Red lines show the discarded behavior. Green lines show the new saved value path. The conversation stays on the left, so you can compare the agent's explanation with the code rather than trusting either one in isolation. Review for intent first, then mechanics. Does the patch solve the requested behavior? Does it preserve malformed data fallback? Did it touch only the intended file? After that, inspect naming, edge cases, and test coverage. Review is where agentic speed becomes controlled engineering. This Git step gets its own explicit prompt. We ask Codex to create a local branch with the configured prefix, commit only the approved filter fix, verify the status, and stop before any remote operation. Local commit authority is not the same thing as push or pull request authority. The agent checks status, creates the branch, stages the intended file, and writes a focused commit message. This is why a clean starting state matters. If unrelated changes already exist, Codex should preserve them and either work around them or stop for direction instead of sweeping everything into one commit. Push and pull request creation require remote authentication and explicit authorization. Before pushing, inspect the branch commits and target remote. Draft pull requests are useful when work needs human review. Never translate a local verifier pass into permission to merge, release, or deploy. For parallel tasks, worktrees are safer than making several agents compete inside one checkout. Each worktree gets isolated branch state while sharing the repository history. Keep synthesis and final verification in the parent task, and give each worker a bounded independent responsibility. The result shows the new local branch, the commit identifier, and a clean status. Nothing was pushed, and no pull request was created. From here, a human can inspect the commit, continue locally, or separately authorize a remote workflow. Codex should never infer that broader permission from a request to commit. Research prompts need source rules. Here we limit claims to official OpenAI material, ask for dates and availability caveats, and require links close to the facts they support. That keeps product education separate from rumor, memory, or a social post stripped of context. ChatGPT is the broader assistant surface. Codex is the work surface for projects, code, tools, environments, and verifiable execution. The app switcher moves between them without making their permissions identical. Codex can search the web as part of a task, but browsing is still evidence collection, not truth by itself. Prefer product documentation, release notes, and primary announcements when a feature varies by platform, plan, rollout, or account. Say that plainly instead of turning partial availability into a universal promise. Product updates arrive at different times across Windows, macOS plans, organizations, and staged rollouts. Confirm the installed build, inspect the changelog, and verify the control in your own interface. If a documented feature is absent, treat availability as unresolved rather than assuming the account is misconfigured. The official material describes the desktop app as a control center for multiple coding tasks, with projects, local and cloud execution, review, scheduled work, skills, and computer interaction. Recent updates also add voice in work and Codex surfaces, plus multi-folder local projects. Treat those as current documented capabilities, not guarantees for every account. A good research answer separates 5 things: what changed, when it changed, where it works, what remains limited, and which source proves each statement. That format is more useful than a list of marketing phrases because it tells you what can actually be demonstrated in this Windows build today. The Sources panel exposes the research trail separately from the answer. In this run, it records repeated searches and the page opening activity. It doesn't reveal every intermediate thought, and it shouldn't. Its job is to make the external evidence inspectable. Browser control works inside a browser surface. Computer use operates visible desktop applications. Image inputs can supply visual evidence, while image generation creates a new artifact. These are distinct capabilities with distinct permission boundaries. For accuracy, you open the cited page and you verify the claim. Notice the link beside its sentence. That gives you a clearer trail than a source pile. We prefer first-party references, and we label inferences so you can see where your evidence ends and your interpretation begins. Skills package repeatable instructions. Personal skills capture your own workflow. System skills provide built-in procedures. A well-designed skill defines triggers, boundaries, required evidence, and reusable scripts without hiding risky behavior behind a friendly name. System skills are useful starting points for documents, media, repositories, and platform tasks. Codex reads the skill instructions before acting, then follows linked references only as needed. The selected skill influences the process, but the user's request still defines the scope. Recommended skills are discoverable capabilities, not automatic installs. Before adding one, check who provides it, what data it can reach, and whether the current task actually needs it. More tools increase both power and the number of boundaries you must manage. The best personal skills encode lessons you genuinely want repeated: how to verify a build, how to stage a safe demo, or how to hand off unfinished work. Keep them versioned, testable, and specific enough that another task can follow them without guessing. Plugins collect integrations such as GitHub, browsers, and files. Installation grants capability, not permission. Reading is different from sending, deleting, publishing, or deploying. Open the Create flow. The Create surface is ready for one bounded local readiness check. Now send the scheduled task. The schedule names the project: weekday cadence, tests, verifier, and local summary. It explicitly forbids repository modifications, network access, credentials, commits, pushes, publishing, deployment messages, and external contact. Unattended work deserves stricter boundaries than an interactive task. Codex finds the saved project and checks for an existing automation before creating a duplicate. The scheduler rejects one explicit start date anchor, so the task retries with the supported weekday at 9 pattern. That visible correction is exactly what we want: a real failure, a bounded retry, and no attempt to conceal the first result. The created automation reports its name, Jerusalem local schedule, project, local environment, checks, output restrictions, and human approval gate. Passing checks will prove only local readiness. The card links back to the schedule, where frequency, model, reasoning, notifications, and active state can be managed. The detail panel makes the unattended contract inspectable. You can read the full instruction, confirm the project, choose the model and reasoning effort, adjust recurrence, and control notifications. The status is active until we deliberately pause it. Now, pause the automation. Now the status is paused, and the paused filter shows the task without deleting its configuration. That's the safe handoff state for a course demo. The workflow remains inspectable and reusable, but it won't wake up later and surprise the user. General settings define the desktop defaults: permission mode, automatic review behavior, file destinations, agent environment, and shell. These are defaults, not substitutes for task-specific instructions. A sensitive repository may need a stricter boundary than your everyday workspace. Appearance changes presentation, not capability. Pick a theme and density that make diffs, terminal output, and long task logs comfortable to read. For recordings, keep the app maximized and avoid resizing mid-task so the interface stays stable. Voice settings control spoken interaction where the feature is available. Voice is useful for steering, clarification, and accessibility, but the same discipline applies. Describe the goal and boundary clearly, then inspect the written task record before allowing consequential actions. Configuration is where Codex behavior becomes durable. Project instructions such as agents.md travel with the repository. User configuration, rules, memories, and related files shape broader behavior. Put stable constraints in durable files. Keep one-off requirements in the task prompt. Keyboard shortcuts make the app much faster once the mental model is clear. Learn the shortcuts for new tasks: search, review, terminal, browser, files, side chat, and panel toggles. Speed should reduce navigation friction, not reduce verification. These plugin settings show the integrations available to the app. Treat each connection as a separate trust boundary. Read-only access, drafts, sends, deletion, and publication are materially different capabilities even when they belong to the same service. Browser settings govern the integrated browsing surface. The browser is useful for local previews and source inspection while keeping context beside the task. A page opening successfully is evidence of rendering, not evidence that the underlying application is correct. Computer use can operate visible Windows applications because it touches the real desktop. Use it only when the task requires interface interaction. Keep the target explicit and preserve a manual abort path. Don't use UI control as a hidden shortcut around missing permission. Hooks let local scripts react at defined points in the Codex workflow. They're powerful because they run repeatedly and quietly. Keep hooks deterministic, fast version, and free of unexpected network or deployment side effects. Connections expose external tools through controlled integrations. Before connecting anything, decide what data may be read and which mutations require confirmation. A connector should expand a clearly scoped workflow, not become ambient permission to act everywhere. Git settings include the branch prefix, merge method, force push policy, draft pull request default, review delivery, and commit guidance. Conservative defaults are valuable. Avoid force push, prefer drafts when review is expected, and make commit instructions explicit. The capstone begins with a plan-only request. We want a release health summary, stronger tests, and a local preview, but no edits yet. The prompt requires a file-by-file plan, verification strategy, boundary checks, and an explicit stop for approval. Planning is most valuable when the task spans several files or contains design choices. Codex inspects the current architecture, identifies reusable modules, and separates data logic, markup, styling, tests, and verification. A useful plan reduces uncertainty. It doesn't merely restate the prompt as numbered prose. Parallel tasks and subagents help only when the lanes are genuinely independent. Give each worker a bounded question, keep shared files read-only when possible, and let the parent task own synthesis, selected fixes, lifecycle control, and final verification. Parallelism is harmful when several workers need the same mutable file. Review the plan for scope, not elegance. Are the fixture and human gate preserved? Does the test strategy cover rendered markup as well as calculations? Is the preview local? Are commit, push, and deployment still excluded? If the answer is yes, approval can be one clear sentence. Fork a task when two approaches need the same history. Cloud delegation runs against a prepared remote environment, so local uncommitted state may not exist there. Mobile handoff and notifications are useful for supervision, but consequential approvals still belong to a deliberate human decision. The plan ends by waiting for approval, and the repository remains clean. This is a real gate, not ceremonial language. The next task should begin only after the human accepts the plan or asks for changes. Approval is explicit. The implementation prompt repeats the boundary, creates a fresh local branch, and requires the full verifier before stopping. Repeating critical constraints at the phase transition prevents the new task from inheriting an assumption that was never granted. Codex now adds the health summary across markup, metrics, rendering styles, and tests. Because the work is local, every claim can be checked against files on disk. The agent can revise its own first attempt, but the final standard stays external. Tests, verifier output, diff inspection, and the unchanged source fixture. When a task looks stuck, inspect the latest tool call, terminal output, permission mode, working directory, and network policy before restarting it. If the conversation has accumulated conflicting assumptions, start a clean task with a compact handoff. Preserve the failure evidence so the new task doesn't repeat the same investigation. Artifacts are first-class outputs. Codex can surface edited files, verification reports, and a local website card inside the conversation. Use those cards as navigation into evidence. They don't replace opening the diff or running an independent check. On Windows, execution may use the native agent environment, WSL, a remote SSH host or cloud infrastructure depending on the workflow. Setup scripts should install dependencies deterministically. Always confirm the current working directory and what state persists before assuming a command ran in the same place as the desktop project. The expanded suite now reports 12 passing tests. The readiness verifier passes, the check marker is present, the diff check is clean, and the release fixture is unchanged. This is stronger evidence than a polished explanation because each claim maps to a command or file. A successful procedure can be packaged as a local skill. Write a clear trigger, preserve the safety boundary, link only the required references, and reuse verifier scripts instead of copying fragile commands. MCP connections expose external tools, a skill explains how to use capabilities, while MCP provides the callable interface. The capstone stops with uncommitted local changes. Nothing was pushed, published, or deployed, and the human gate remains. That ending demonstrates the full Codex loop. Research the context, plan, obtain approval, implement, test, inspect, and hand back a reversible result. Personality affects tone, not authority. Memories can preserve useful preferences, but durable repository rules should still live with the project. Organization administrators may enforce settings that override personal defaults. When the interface differs from a tutorial, check policy, platform, build, and rollout before blaming the prompt. The side panel keeps tools beside the task. The browser is ready, so enter the loopback address and keep the local preview beside the work. The Launch Pulse preview renders inside Codex while the verified result remains visible on the left. It shows 6 services, 50% ready, 2 needing attention, 1 blocked, and the human gate warning. Test the filter. Attention is selected, and the list narrows to services needing review. That's the bug we just fixed. Now, reload the page once. After a real reload, attention remains selected and the list stays filtered. That's the final proof. Repaired behavior on screen. We begin this advanced pass in a fresh local task. Before touching the plus menu, confirm the project environment and no write boundary on screen. Next, we'll attach the real guide, enable a persistent goal, and delegate 2 narrow read-only lanes. Next, open the attachment menu. Now we're moving beyond ordinary prompts. The plus menu gives this task a real source document, the project release readiness guide, right here. The Windows file picker is part of the proof. We're not pasting a convenient summary or asking Codex to trust our memory. We're attaching the exact file the workers must inspect. The composer also exposes goal mode. A goal helps an objective persist through longer work, including worker activity and follow-up steering. It is not a promise of success. It is a durable completion contract, and Codex should finish it after every required check is accounted for. Right here, we add the bounded worker prompt 1 careful line at a time. Look at the prompt. It asks for exactly 2 read-only workers in parallel. One lane checks test and verifier behavior. The other inspects the release artifact and human approval boundary. Naming the lanes prevents vague delegation, while the read-only rule keeps discovery separate from any repair. The parent task remains responsible for synthesis and for deciding when the goal is actually complete. The final line blocks rights, deployment, credentials, and every form of network access. The completed prompt shows every safety boundary. Both workers are now visible in the environment panel. Notice the 2 separate lanes on screen. Parallel work should be inspectable, not merely claimed in the final answer. Each lane has a narrow job, and the attached guide appears under sources, so the parent and both workers are reasoning from the same evidence instead of drifting into separate interpretations. The audit has found a useful complication. The verifier is not truly read-only. It writes the readiness artifact as part of its normal run. That is exactly why boundaries need to be operational rather than decorative. The task does not bulldoze through the conflict, it records what the command would change and limits further work to checks that preserve repository state. While the goal is still running, a steering message tightens the final synthesis. Steering is for new information or a sharper decision rule, not for repeating the original prompt. Here, it asks the parent to distinguish tests that genuinely passed from verification that was intentionally withheld and to explain the right boundary without pretending the blocked command succeeded. The completed goal shows both workers finished, the test suite passed 12 out of 12, and the mutating verifier wasn't rerun. That wording is deliberately precise. A useful result reports what happened, what was skipped, and why. It doesn't compress every outcome into a cheerful green summary. Goal completion is also visible as a lifecycle event with elapsed time and token usage. The parent synthesis includes the steering request and all 8 requested checks. That is the right moment to mark the objective complete, not when the work feels long enough, but when no required item remains unresolved. A work tree begins with a fresh task because the environment choice controls where every later command lands. First, confirm the project and local context, then bring up the environment menu before adding any repository request. Next, the environment menu creates a new work tree. A work tree is a second checkout connected to the same Git repository with its own working directory and branch context. It is the safer choice when a task should inspect or change code without colliding with uncommitted work in the main checkout. Now, focus the isolated task. First, the request asks for the work tree path, branch, Git status, and recent commits. Then it compares the isolated checkout with local notice how the evidence comes before the authority boundary. The last line keeps it read-only and blocks every external action. The closing line makes the task read-only and keeps every external action out. The result now names the actual worktree path and its branch, confirms a clean isolated checkout, and compares it with the foreground local state. At the top, the environment panel says worktree, while commit and push remain unavailable. That combination is stronger than a conceptual explanation because it proves where the task ran and what Git state it could see. We are back in a local task to package a reusable project skill. A project skill lives with the repository, so its instructions can travel with the code and be reviewed like any other change. The goal is not to hide a complicated prompt. It is to turn a proven procedure into a small, explicit contract. Open the environment menu. The picker is open. Choose the local environment. Focus the skill composer. The skill creator call appears first, followed by the launch pulse readiness package name. The prompt then builds the procedure in layers. Next come the repository contract, tests, verifier, and exact marker. The final clauses preserve human approval and block rights, network access, credentials, commits, pushes, publication, and deployment. The remaining clauses keep narrowing what this workflow is allowed to do. The final line excludes commit and push, keeping this whole workflow inside the local task. The finished skill request is ready. Send the package request. Codex now reads the authoring guidance and keeps the package inside the requested project. The verifier's artifact write creates a real design problem. The skill needs to execute the required command while proving the repository remains unchanged. Codex responds with a bundled guard and runner rather than silently weakening the requirement. The guard captures the original tree, constrains allowed commands, suppresses the known artifact write, and checks the snapshot again afterward. The first forward run exposes a Windows PowerShell 5 compatibility issue. The available .NET runtime does not provide path.getRelativePath. No verification command ran, so the repository stayed untouched. Codex replaces the incompatible call with a root prefix calculation, validates the scripts again, and continues. Keeping this failure visible makes the workflow more trustworthy, not less. The corrected package now runs the guarded readiness loop. It executes the declared npm commands, blocks unexpected writes and network attempts, and compares the repository snapshot before and after. This is the important distinction between a skill that merely says read-only and a skill that contains machinery to test that promise. A second, live issue appears in command routing, and Codex follows the observed failure instead of declaring the scaffold finished. The repair is narrow. Adjust only the policy behavior the runner just disproved, then repeat the package validation and the guarded run. This is the loop we want a reusable skill to encode. The final proof is now on screen. The package validator accepts the skill. 12 tests pass, the verifier exits 0, and the exact readiness marker is reported. The repository snapshots match, the blocking probes pass, and the existing dirty artifact isn't overwritten. Each line answers a different question, which is why a single green badge wouldn't be enough. You can also see what the package did not do. No commit, push, publication, deployment, credentials, or external action. Human approval remains required before launch. That sentence is not legal padding. It prevents local readiness evidence from turning into release authority, and it gives every future invocation the same safe stopping point. Now we'll use the project skill from a fresh local task. A clean task makes the invocation easier to audit. Because the instructions and result aren't mixed with the package authoring conversation, the project still supplies the skill, the branch, and the repository contract. Start a fresh task. Open the environment menu. Keep this task local. Focus the skill composer. Notice this. You start with the project skill name, making reuse an explicit choice. Enter the explicit skill call. The request now moves from method into evidence. Here come the test count, verifier result, and readiness marker. And the closing clause keeps every external action behind the human gate. The finished message preserves today's evidence and human gate. Run the package workflow. After the message is sent, Codex recognizes the project skill and follows its required files and guarded runner. Notice the visible work log here. We can see that the task is reading the contract and executing the packaged workflow rather than answering from the words in the prompt alone. The invocation returns readiness, pass, the exact marker, and a matching repository snapshot. It also lists the required files it used. This is what reuse should look like. The same checks and the same evidence format produced from a short invocation instead of rebuilding the safety logic in every new task. We can see each proof on screen. The result finishes with the remaining limitation. This proves local package readiness only. The artifact write was suppressed, and no network, commit, push, publication, or deployment occurred. Human approval is still required. A reusable skill is valuable partly because it repeats this boundary even when the operator forgets to restate it. The capstone now moves into review. Start a separate maintainer task. Open the review environment menu. Keep this review local. Now focus the review composer. The review request begins with the current branch, and its uncommitted changes, then it sets the skeptical maintainer posture and names the feature, tests, artifact, and project skill. Only after that comes the crucial limit. Report concrete defects, but do not edit or repair them yet. The request is still finishing its safety boundary before the stop. And it stops before repair. The review stops before repair. Send it without repair authority. The task reads agents.md, inventories 11 uncommitted paths, and examines the complete diff. Look at this part of the work log. It also invokes the project readiness skill, because that skill is itself part of the change set. One workflow can reuse another, while the parent task keeps the broader review responsibility. The review finds a serious guard design concern. Several two-path file system operations validate only the first path, and the runner does not fully contain child process, writes, or networking. Passing the package's own tests did not prove those missing cases. This is exactly why independent review needs to challenge the assumptions inside the validator, not merely rerun it. Codex still runs the declared guarded loop to capture what the current implementation actually proves, then compares the work tree again. This does not erase the static finding. It separates two facts: the existing happy path can pass, and the guard still has bypasses the happy path does not exercise. Both belong in the final review. The review comments are now visible with exact files and line ranges. Notice the priority labels on screen. The top findings are all priority 1, a destination path bypass, invisible Git mutations, and a simulated artifact write that doesn't faithfully model the real verifier. 2 additional comments complete the set. This is actionable feedback, not a vague request to make the code safer. The screen stays on the findings for a reason. Read the priorities before approving anything. Destination path validation, hidden Git mutations, artifact freshness, strict release states, and integration coverage. Approval should follow the evidence, not arrive while the review is still forming. Return to the review composer. The follow-up starts by approving only the reviewed corrections. Tests come next, followed by the readiness verifier, skill validation, final diff, and 1 local commit. At this point, the message is still defining local work. That order is deliberate, because local evidence should be complete before external authority is even considered. The boundary arrives last: no push, pull request, publication, deployment, or any other external action. The external stop is visible. Send the bounded repair request. Codex acknowledges 5 approved corrections and explains the repair plan before editing. The work will tighten the guard at its enforcement points, make artifact validation freshness aware, fail closed on unknown release states, add integration coverage, and preserve the human boundary. The scope is larger than a one-line patch, but it is still bounded by the review. The repair is now editing the approved files. The changed file counter grows while the task remains on step 1 of 4. This is not a reason to interrupt it. A deeper safety repair often touches policy, runner behavior, feature code, and focus tests together, and the following verification steps are part of the requested outcome. The visible status moves from child process policy to release summary behavior and strict status handling. We can see the progression. Remove the security bypasses, then make the readiness output fail safely when the underlying state is unknown. The long-lived work remains authentic, while the final edit keeps only the evidence-rich moments. The repaired feature now reaches its first verification gate. The normal suite passes 20 out of 20, and the standard verifier regenerates a pass artifact with the new tests. That proves the intended behavior still works. It does not yet prove the stricter guard can safely permit the declared commands while rejecting everything else. The first guarded run fails for a productive reason. Right here, it preserves the repository snapshot, but denies npm's lifecycle launch more narrowly than intended. Codex exposes only the blocked command shape, not environment values or secrets, then tightens the allow list to that exact invocation. A fail-close guard should be repaired from observed evidence, not relaxed broadly. The rerun keeps the allow list narrow. Only the declared npm lifecycle commands and the verifier's nested test process are permitted. Destination writes, undeclared SO processes, direct sockets, artifact drift, and command substitution remain covered by focused tests. The point is not to block everything. It is to make the allowed path explicit and measurable. The guarded workflow now passes end to end. Both npm commands exit 0, the artifact matches the current verifier payload, and the snapshots including .git match. Look at the status line. The task moves to package validation and final diff review. This is the recovery moment. The live failure changed the implementation, and the repeated proof confirms the change. Final verification is clean so far. 20 tests pass. The readiness artifact contains the exact marker, and the skill package validator reports skill is valid. Codex inspects Git status, checks the diff, and prepares to stage only the intended paths. Validation here covers behavior, package structure, and repository scope before commit. The authorized action is one local commit, and that is where the task stops. A commit creates a durable review point without contacting a remote push, and pull request creation would cross a separate authentication and collaboration boundary, so they remain disabled. The capstone is complete locally, but it has not been released or published. The final result reports a clean worktree, a valid skill, passing readiness evidence, and the local commit. The commit is real, 1E36FDB, titled Add Release Health Readiness Checks. The environment panel still shows local, and commit or push is unavailable because there is nothing left to stage. The closeout repeats the boundary one final time. Local and offline evidence passes, while human approval is required before launch, deployment, publication, or release approval. No push or pull request was attempted. This is what a complete local engineering loop looks like when completion and external authority are kept separate. The task menu collects lifecycle controls around a completed conversation. They are all visible on this page. Pin or rename it, archive it, start a side chat, copy content, continue in another context, add a scheduled task, or view it in a new window. These options organize or branch the work. None of them changes the evidence inside the completed result. Open the site's workspace. Sites has its own workspace and composer. It can turn a supported local project into a saved site version, and with separate authorization, a production deployment. Those are not the same step. This workspace makes the boundary clear. We are not choosing a project, sending a build prompt, saving a version, or publishing anything. That distinction matters here. The Create surface asks what to build and which project should supply the source. This is the publication gate in practical terms. A preview can still be local or saved without becoming public, while every production deployment needs explicit authorization, a known source revision, and a final access decision. We don't cross any of those gates. Close the Create menu. The integrated browser opens with Ctrl-T, which is more reliable than aiming at a tool card whose position changes with the layout. The browser lives beside the task, so a source can remain visible while you work. It is useful for documentation and runtime proof, but the page itself is still untrusted input. verify the domain and the claim you are using. The address bar now shows learn.chatgpt.com, an official OpenAI learning domain. The page title is ChatGPT Desktop App. When product behavior can change, use a first-party source like this instead of relying on an old screenshot, a social post, or a remembered feature name. The official description calls the desktop app a command center for complex work. This line beneath it names the same capabilities we've just used: parallel projects, files, computer interaction, and long-running work inside one desktop workspace. Our course has treated those as concrete workflows, not as marketing labels. That brings the full loop together. Start with the right project and environment. Write a bounded prompt, attach real evidence, let Codex work. Steer only when new information matters. Inspect the diff and tests, and stop at the correct human gate. The interface is powerful, but the durable skill is learning how to ask for proof.